In this video, I'm going to give an overview of section 4.2 on null space, column space, and linear transformations. Okay, so in the last section, we talked about vector spaces and subspaces. The null space and the column space are examples of subspaces that relate to some matrix. Okay, so our goals for this section are going to be to first talk about what the null space and the column space are, but once we do, when we're given some matrix A, to be able to check if a vector is in the null space, and to also explicitly find what the null space is. And as we'll see in the next video, doing those two things aren't really going to be new. This is going to be mostly to review from stuff that we've seen, just under the framework of this new terminology. We'll also do things with the column space, but we'll sort of break that up into stuff that we'll see in this section and stuff we'll see in the next section. So in this section, we'll learn how to check if a vector is in its column space. In the next section, we'll learn how to find what's called a basis for the column space and for the null space. Okay, the second main learning goal is to be able to show that the null space and the column space are in fact subspaces. And then the third main learning goal is to generalize this notion of null space and column space so that we're not just talking about matrices, but we can talk about linear transformations. So the context of linear transformations, the analog of a null space is what's called the kernel of a transformation. And the analog of column space is what's called the range. And the range we've actually seen before. So kernel is going to be a new term, but each of these terms is going to be related to the concepts of null space and column space, which we will see first.